Okay, so today I figured we'll do some modeling exercises, putting into practice some of the stuff we've been learning this week, as well as do a little bit of a review, because really there's no such thing as doing modeling without also doing kind of some exploratory data analysis as well. So it's both an opportunity for us to think about what do we do when we first get a data set, and then when we model, what do we do with that? And we have one more week of modeling content left. So I'll say a few words about what's to come towards the end of this session when we're kind of evaluating our models, because we've taught you how to fit models, and we've taught you about what are the things you might want to watch out for in terms of overfitting and stuff, and given you some tools to deal with that. But we still have not covered then how do we evaluate which model we should go with. So that's going to be a majority of what we're doing next week. So I'm going to go ahead and share my screen as usual. If you have any questions, just put them in the chat, and I will try to keep my eye out for them as well as I can. And also we'll try to give like 5 or 10 minutes at the end for general questions too. And if we run out of time, I'm happy to stick around a little bit longer. Let me make this a little bit bigger. Okay. All right. So the data set we're going to work with is a data set that should be familiar to you actually, because we've used this data set at the, I feel like maybe week 3 or so of class when we did data wrangling, and it was the hotels data set from Tidy Tuesday. So let me remind you what it was. So I'm going to load my packages here real quick and also load my data. And this is the Code Along project is on RStudio Cloud if you do want to follow along. So let's take a look at this hotels data set. Remember that this data set was from a paper that was actually, the goal of the paper was trying to build a model for predicting the is canceled variable. So some hotel bookings get canceled and some don't. And in fact, if we quickly take a look, and I'm going to do one thing here. I feel like this is going to make it a little bit easier for you all to follow along. So let's put the console on this side. Okay, so if we take a look at the is canceled variable, you can see that there's a huge number that are canceled, like about 75,000 bookings that are not canceled and about 44,000 bookings that are canceled. I don't know, when I make a hotel booking, it actually would take a lot for me to cancel a booking. But if you also remember from this data set, we have a lot of like different types of bookings here. So I think that was in the market segment variable. You can see aviation, for example, corporate bookings, groups and stuff like that. So these are the sorts of things people are making business arrangements, and chances are they don't get the terrible cancellation fees that we would get as individuals making hotel bookings. So they're a little bit more flexible about it. So that's what the paper was about predicting the canceled variable. But when we first explored this data, we had taken a look at the number of kids in the room. So the example we had given was there were some rooms where we had like some babies in the room, but no adults, if you remember from the application exercise. So we're gonna go back to the data and actually create some new variables and then work with those in terms of are there children or not. So I'll start by simple data preparation using just dplyr. Something is weird with my coloring here. What's going on? See how? Anyway, oops. Mutate. So let's say little ones, we can say is the number of children plus the number of babies in the room. And so if I run this, it becomes a little bit hard to see if I got anything correctly, as you can tell, because that variable is all the way kind of towards the end. So one of the things I like doing when I am trying to create new variables is I use the relocate function. to move the ones that I want to the front. So this is different than select because it's not then omitting the other variables, but it's just moving these to the front. So now I can see that little ones is here, and we have a bunch of zeros, but we could probably also just do view on this real quick to open it up here so that we can sort things a little bit more easily. There are a lot of observations, so maybe it takes a second for it to do that, just to make sure that it's doing things correctly. And in fact, it's doing the calculation correctly. So that's the number of little ones in the room. So the difference between relocate and select with everything is the same. So I could have said select and then basically move those up and then add everything here. So I could have done that and that would have given me the same thing. It's just more things to write. So relocate is a function that I can use for that as well. I'm going to quickly close this document and reopen it so that that weird coloring goes away. There we go. And then to answer Nabil's question, the way I moved the console to the side is I went to the global options, and you can actually change your pane layout. So I selected console here just because I think it's a little bit easier for you all to see. When I watch live coding videos, I like it when the console is over on that side. Okay, so we have this variable little ones, but what I want to do actually is not to predict the number of children, but actually if there were any children in the booking or not. So what I can do is, now that I know how to create this variable, I'm going to create one more. Has little ones is basically, we can make it an if else statement where if little ones is greater than 0, so that would be 1 and above, we can call this yes, otherwise we'll call this no. And let's move this to the front just to make sure things are working properly. And in fact, for the zeros, I am getting no's here. Okay. So this is going to be my kind of the variable that I work with throughout. The variable that I'm going to model is going to be this has little ones variable. So I will, now that I'm happy with my code working, I will overwrite my hotels data frame by assigning it to that. And I don't really need these children and babies columns at the beginning anymore. In fact, I don't even need this one at the beginning anymore. I can just use the has little ones at the beginning, just because that's going to be my response variable. I can print it out and take a look at my data with my response variable at the beginning. From a modeling perspective, it doesn't matter where in the data set your response variable is, but from a like ease of use perspective, it's nice to have it there so you can always see it. A couple other things I like to do when I create variables like this is just to see, did I do things correctly? So if I was to, count, the new variable I calculated has little ones, and the one I calculated before that, I can see that when the number of little ones is 0, I get no, and for everything else, I get yes. So that's just like a nice sanity check to make sure the recoding has been done correctly. You can see what I'm doing is I'm developing my code in my R Markdown document. And then once I'm happy with my pipeline, I'm overwriting it onto my data frame. And then every once in a while, I'm running these statements here in the console because I know that they're not necessarily going to be part of my final analysis, but it is for me to confirm that I'm doing things correctly. We are going to look at predicting the number of, whether or not there were any little ones in the room for hotel stays. So what I'm actually going to also do is create a new data frame called hotel stays, which basically takes the hotel's data frame and just filters it for is canceled, is 0. So these are all the ones that are not canceled. Okay. And if I take a look, that's 75,000 hotels versus the hotels. the original data frame had almost 120,000 with the canceled reservations, and now I have just about 75,000 observations that I'm going to be fitting a model for, okay? So here, maybe my code chunk name would be something like filter for not canceled, okay? Now, another thing is, now I have this is canceled variable in my data frame, right? And it's possible that I don't actually need that variable. I mean, I don't really need that variable going forward, because now all that entire column just has ones in it, right? The is canceled variable just has ones in it because I've gotten rid of all of the zeros. And there are other variables. If I take a look at the variable names in my data frame, there are many variables here, some of which I'm going to use and some of which I'm not going to use for my modeling. So we haven't really yet talked about a principled way of doing model selection. There are some methods out there for model selection where, there's a function, I can run it in R, and then it will spit out a model that is supposedly the best, depending on some statistic. Somebody decided this is a good measure for the performance of models, and we're going to fit all the possible models and then give you the one with the set of variables that gives us the best value for that measure. These are called automated model selection methods, and we'll talk a little bit about them next week. But they don't tend to be actually very principled. They're really bounded by how much computing you can do, but then you've never really thought about your data. So what really I would like you to get out of kind of this course is thinking about how are we modeling this with things that might actually be useful for us, with things that we're actually interested in. Just because a variable isn't a data set that you found may not necessarily mean that you're interested in that, for example. So I'm going to narrow our focus down to a subset of these variables to begin with, and then we're going to do some exploration first before we fit the models so that we can actually have some develop some hypotheses in our head about what we might expect to get when we fit the models. So the variables that I'm going to use for my data set that I'm going to fit a model to is, let's see, which ones would be. So obviously I want to use the has little ones, right? And then we're going to use hotel type, which was the hotel variable. This was the one that told us about whether it's a city hotel or a resort hotel. I don't need the is canceled variable anymore because we already said that we filtered out all the reservations that were canceled. I can use lead time. We also have a bunch of information about arrival year, month, week number, or day of month. I'm going to stick with arrival month, and we can take a look to see if there are some patterns there. Stays in weekend nights and weeknights, both of these we can use. We also know how many adults we would like to use that in our model. Now, we also have these two variables, children and babies. Should we include them as predictors in our model or not? If we want to predict has little ones, what do we think? No, why not? Why would it be why should we not include them as predictors? Right, we shouldn't use what you want to predict to predict it, right? We basically calculated the has little ones variable based on the counts of those. So here, this is a good example of like, is that actually the type of information you would have for the next hotel booking? No, if you already knew how many children and babies are in the reservation, then you have the answer. There's no reason for doing any prediction. In fact, depending on what you are trying to do, you might want to include the adults variable or not. You know, maybe you're trying to predict whether they'll bring a kid along with them or not when you know how many people are in the room, or maybe you want to predict it before you actually have any information on how many people are going to be in the room. So depending on the use case for your model, you might use these variables or not. There are a few other variables that might be of interest. The meal type, did they require parking spaces or not? There may be the room type, and then I'm gonna grab a couple others. Market segment, the average daily rate, and then let's take a look at these special requests as well. So the data frame that we're going to use basically is going to have just these variables. We're going to try to predict the has little ones variable based on the other ones. Now that we have this data frame, some things that might be useful to do would be to maybe, you know, glimpse at the data frame. This is a useful way of looking at your data, to take a look at various data types that you have and get a sense of the types of information you have in your model. Another thing that might be useful is the skim function. So let's take a look at that too. And I'll expand this a little bit and run it again, just so we have everything. Oh, one more time. I'm trying to get everything on one round. There we go. Okay, so we have 75,000 rows in our data frame. Some of them are character variables, and we can see that we don't have any missing data, so we don't have to worry about that. We can see the number of unique observations can be useful for us to also take note of, because when we're doing prediction, and if you have many different levels in your data frame, sometimes it might, in a variable, sometimes it might be useful to think about lumping things together, especially if your sample size is low. In this case, we don't have a low sample size, but still that's something to keep in mind. So the n unique data frame is something I always try to take a note of as well. But you can also, you know, take a look to see if we can also take a look at, let's see, the numeric variables. And here these histograms are sometimes helpful to give us some sense of our data distribution. So the number of adults, for example, we can see has a left skewed distribution. So it's probably something like some with very few observations with 0 adults in the room, some that are 1, and many that are 2. People tend to, you know, stay in hotel rooms as pairs, if that's the case. So if it's especially not a business hotel, you would probably see more couples than single people staying in the room. The required car parking spaces. So this one is probably like a lot of people either require 0 or 1 as opposed to many more. We can also see the average daily rate, which is basically the cost of one night of stay, is right skewed, which is another thing we would probably expect. Probably unlikely to have very, very expensive rooms. So let's take a look at, so once you have a sense of your data frame, before we fit our model, another thing that would be useful for us is to kind of explore the data visually. So let's make some ggplots here. I'm going to make a plot of hotel stays. And what I actually want to look at is the parking variable. So this is the required car parking spaces. Something I might do is take a look to see what sort of observations I have here. So these are just 0s and 1s, I think. Another way of looking at that would be hotel stays, and I can look at the distinct observations for required car parking spaces. Oh no, it's 0s, 1s, 2s, there's some 8 and a 3. But chances are, so I have 0 or 1 or more and very few of them. So I think what I might do is actually create another new variable here. And I might just go ahead and do it at the beginning and say, if else required parking spaces is equal to 0, make it a no. Oops. Otherwise, make it a yes. Does that make sense? So it's just so few, like the distinction between 2s, 3s, and 8s are just like so little that we might as well lump them all together. So now what I've done is I've gone back and did something over here. So I might as well run my, run that particular chunk and just take a look to see if I buy these results. What was it? Required car parking spaces. Yeah, so I have yeses and nos. And then I remind myself, this is where I was. So I'm going to run all of the code up to this point one more time. Okay, just so that all this filtering and stuff is now applied to the new data frame. And so let's say that I am looking to see the has little ones variable. And I'm going to fill my columns with the required parking spaces, such long names of variables. Geom bar. Let's take a look to see what this looks like. Okay, so if maybe doing position fill would be good to see if we're seeing differences. So it looks like if you have children with you, you're more likely to ask for parking spaces, for example. And another thing we might do is facet wrap for the hotel type. Maybe let's do, put them all in one column, something like this. And that is true whether you're in a city hotel or a resort hotel, but in general, in resort hotels, people are more likely to ask for parking spaces anyway, which hopefully makes sense that they would be more likely to do that. Another thing we might look at is the month. So I'm going to copy this, but this time I want maybe on the x-axis, I want my month, which was what? It had a arrival date month, and let's fill it in with this has little ones variable. All right, does anyone remember what's wrong with this plot? I think we've looked at this variable before in a previous application exercise. What do we think is wrong here? The order is wrong, right? So we can actually fix that order. And remember that there is a object in R called month name that we can actually leverage for fixing that. So the way I'm going to do this is I'm again going to go back to my data prep chunk and say, this is arrival date month is, let's re-level the arrival date month variable, but the order that we want to use is month name. And let's go down to where we were. I'm going to run all of the code up to this point again, and then run this one. Now my months are in the correct order. And let's do position dodge. So we can kind of see without the proportions, kind of the counts, what is happening. And it looks like in both hotel types around July and August, so summer months in the US, I think these were US bookings, we're seeing more bookings with kids than the other months, which hopefully makes sense as well. Okay, the one other thing I wanted to show you all is this function from a new package called, I always thought this package's name was ggalley, which doesn't make any sense. Apparently it's ggally, like an ally to the ggplot package. So it is what it is, but it has a really nice function called ggpairs. And so I wanted to show that to you. And let's take this hotel stays data frame. Let's give this a go, but it's going to take a second for this to run. And it does take a little bit of time for this to run. So you'll see that it gives you like a progress bar for doing so. The reason why it takes a long time is because I am working with a large data set here, and we have a lot of variables that we're trying to make the plot for. This is the most frustrating thing of progress bars, where they just like kind of get stuck at the end and you wait and wait for an undetermined amount of time. All right, let's see if the plot is here. Can you handle it? Why not? You know what? Let's do something to make our lives a little bit easier and to get rid of, oh, there it is. I'm going to get rid of some of the variables that we had to begin with, just to make our lives a little bit easier. But let's take a look at this. So what this function does, and this is why it takes a long time, is it's making lots and lots of plots, and it gives us pairwise plots for all of the variables in our data frame. So we can look at the relationships between all of them at once. And what it's good about is knowing what type of plots would be actually useful for the types of data variables you have. So for scatter plot, so for numeric data, you get scatter plots, versus for categorical data, you get bar plots. But it is really choking. So let me see if I can do this with a fewer number, just in the interest of time. What might be some things that are not as interesting? All right, let's reduce these things a little bit, okay? And I'm going to go ahead and run everything up to here. You can see that this thing is like my best friend. I'm like constantly running everything up to a particular point because I'm changing my mind about what I was doing with my analysis and making sure that whatever point I'm in my analysis, I'm actually able to make, I'm trying to make sure that all the code that I adjusted from earlier actually gets run. And this is a very iterative process. I didn't come to this session like with a very clear idea of exactly what I wanted to do. I looked at the data set to prepare, but I'm trying to kind of mimic what you might be doing with your projects, where you take a look at something and then you change your mind and then you take a look at something else. Come on, RStudio Cloud, you can do it. There we go. Okay, so now we can take a look at some of the relationships between the variables. And we have here, so on top, we have the has little ones variable, which is going to be our response variable. So we can take a look to see, for example, the average daily rate seems to be higher when we have more with children in the room than without. And you know, another thing that might be useful for this plot, even though it's going to make us wait for a second, is I believe we can actually color things by the has little one. So we can actually add a mapping here, and we can say color it by has little ones, because that's ultimately what we're interested in, right? And how about, here's another tip for you if you're working with a large data set. Sometimes it's useful to try out your code in a small data set, and if it's working, so I'm going to just randomly sample like 1,000 observations and try to make the plot for this random sample of 1,000 as opposed to all 75,000. Just take a look to see if the code is working. Did I do things correctly? Once I know that it is okay, then I probably will want to, you know, update things so that I'm running my analysis on the full data set. But it's useful to be able to generate these things if your code is taking a little bit of time to run. So now we can actually see a little bit more easily between the different colors how the two correspond to each other. The green ones were the ones that had little ones, and the red are the no's. So we can compare, for example, the average daily rate between the two the ones with kids and ones without. We can even look at them even with parking spaces. We're seeing that there's a difference in the average daily rate, for example. So this is the sort of thing that's honestly probably not going to be part of my final write-up or presentation because there's too much here, but it's useful to see everything at once and then to drill down and say, maybe I'm curious about this particular plot. Let's actually make that plot and take a look to see what's going on there. So it's a very useful exploration tool. I wouldn't say it's a very useful presentation tool because it's really hard to look at this and quickly understand what's going on, but you might make a plot like this and spend some time with it for a while and then decide, here are 3 interesting things I actually want to talk about in my presentation. Okay, so now we can actually build our models. The one thing I'm going to do in order to set myself up to build my models is, let's take a look at my hotel stays data frame. I have a bunch of, I have one factor variable here, the arrival date month, but then the other ones are characters, right? And I actually would like those to be factors as well. So I want to actually mutate my data, and I'm going to say this is basically the data frame that I'm going to be fitting my models to. It's the hotel stays data frame, and I want to mutate to say anything that's a character, I actually want to make it a factor, okay? So I can look through my data frame and say, which ones are the characters? This is a character, and then this is a character as well. So I want to make these into factors first. The thing about this approach is that it's like a little bit annoying, especially if I had more variables, this would get more annoying as well. So this is what I'm trying to do, turning them into factor variables. But there's actually a quicker way that I can do this. And I don't think I've covered this in the videos, but I figured like it's a nice reason to try to teach this. So we could actually write this in a way where we're saying, any character variables in the data frame, convert them to factors without us explicitly telling R which those variables are, because it should be able to know which ones the characters are. So the way we would do that is another function in R called across. So basically we want to go across columns, and we want to say where the variable itself is character, because that's the function we would use to check for character, make it as factor. So apply the as factor function to it. So let's go ahead and run this and do a glimpse at hotels DF. So now we can see that those that were characters before have now been converted to factors. So it's a useful way of doing things. So here, the key thing is we're going across the columns. We're using the where function to say, like, take a look to see which of these columns have a particular feature. And remember, the is character function should give us like a binary true or a false, depending on whether the variable is a character. And then we're saying whenever you get a true, convert it to factor. So as factor actually does something, it converts the type. More important than what these sequence of functions are is the fact that as we're learning more, we're going from writing things out more manually one by one to thinking about, I wonder if there's a shortcut way of doing this. And with only 3 variables that we had to convert, is it worthwhile to learn something new versus just know what we used? I don't know. I think that could go either way. If we had 30 variables we had to convert from characters to factors, I think we could all agree that this is worthwhile learning about. So we have our data frame, and the first thing we're going to do is split things into training and testing. So we'll do a hotel split. And the function from the tidy models that we are going to use is the initial split function. So I wanted to show you the help for that function because I don't think I've done that in the videos. In the videos, we've taken 80-20 split between our training and testing data. And we could do the same thing here as well. Another commonly used proportion is like 3/4, so 75% for your training, and then a quarter of your data for your testing. So if you actually don't tell the proportion, then it will do the 3/4 by default. So I don't think I've shown this default in the video, so I wanted to show that to you here. And then what this does is it basically creates an object that tells us which the various splits are going to be, okay? But the two things that we want out of this is we want a hotel's training data frame, and we also want a hotel's testing data frame, our holy data frame that we're not allowed to touch until the end, right? So the function we extract the training data out is training. And the function that allows us to extract the testing data out is, whoops, testing, sorry. So let's go ahead and do this. And then we can take a look at the dimensions of these two data frames. And we have about 56,000 in the training and about almost 19,000 in the testing, the 3/4 to quarter split. Okay. Now let's run this one more time. And then take a look at the dimensions. Oh, actually, I am getting exactly the same dimensions. So I guess these numbers were divisible. So I am getting exactly the same thing. Maybe we can do this. We can say, find for me the mean in my hotel's training data, the mean ADR. I bet there are NA, so I'm just going to add this here. So right now, the mean average daily rate in my training data set is 99.82. Okay, let's go ahead and run this again and then try that again. Now that's a little bit different. And if I run it again and find the mean, that's a little bit different. What's happening? Why are those numbers different from each other? Any guesses? Exactly, I didn't set a seed. So this splitting is happening randomly, right? So I really need to set a seed. So give me a number and I'll put it there. Any number. No one wants to give me a number. While you guys are giving me a number, I'm going to look for a blog post for it because I think it's really interesting. Seed. See if I can easily find this blog post. There we go. So Maya is a statistician and an R programmer, and she writes really nice blog posts. It doesn't matter how big a number. And she basically analyzed data from GitHub repos where people had R code in it, and then took a look to see what are the common seeds that people said. And it looks like these are the common seeds that people said. I think some people actually set this number elsewhere and then pass it on. But you can see 1, 2, 3 is very common. 1, 2, 3, 4 is very common. You can often guess if you look at people's code when their birthdays are and stuff, because that's the seed they tend to set. So what the set seed is doing is, let's think about it this way. Back in the day, there used to be random number table books. Like it would be a book on your shelf and it would have a bunch of random number digits in it. So if you needed to do anything with random numbers, you would open it up and then pick a random number from there. Because if you tell me to pick a random number, I'm probably going to pick my birthday or something like that. You know, like humans don't actually generate random numbers. So what we are asking R to do is to say, next time you're going to sample, you need to start sampling somewhere, like with a particular seed. So that actually, that seed, that number gets fed into a pseudo-random number generator that allows us to then draw a random sample from our data. But even though I want that sample to be random, I also want it to be the same random sample every time I run my analysis. Otherwise, when I knit the document versus when you knit it, or I share it with my collaborator, they're going to get something else. So what the setSeed function does is, it's almost like if we had a random number book, it would be about how to, which page to go to or something like that. You're still looking at random numbers, but there's some direction as to where to get started. So, all right, we will go with this. Oh no, I can't, oh my God. I can't copy from the Zoom because heaven forbid the terrible things that could happen if I copy it from Zoom. Okay. So now if I find the mean and then I run it again and I find the mean again, I'm getting the same number over and over. Does everyone know how I'm scrolling through my previous code since you can't see my fingers? So what I'm doing is I'm putting my cursor in the console and then just clicking on the up arrow, and I can go back and scroll through. So if you're quickly trying to do things like, oh, let me do this again, and then run that mean code again, I can quickly scroll back and do that. Okay. So here's our testing and training data sets. So the next thing we're going to do is to build a recipe. So let's go ahead and say we're going to build a recipe. Our recipe starts with what our model should look like. So it's has little ones is our response variable, and we're going to use all of the other variables as our explanatory variables. And the data, we're going to build our recipe based on the training data. What are some things that I might need to do? One of the things would be to create dummy variables, right? Because I have some factor data in my data frame, so I can run a step dummy. And what I'll do for that is say, take all of the nominal, so factor variables, except for the outcome variable. How does this recipe know which one is the outcome? Because I specified it here. That's why I start specifying my recipe with what my model will look like. Here is the outcome variable. Everything else is called predictors. And this is the data frame it's going to come from, the hotel's training. Because when I say things like look for all the nominal variables, R needs to know, where do I look for them? Well, look for them in the training data set. And then another thing that we usually like to do, if we have any zero variance variables, because we had some numeric data and we very well might have some columns where there's no variance in our column. So all of the observations are the same. So this is something that I almost always add to my models if I know that there are some numeric data. Okay. So now we basically have this recipe. And what this recipe has is just some instructions. We haven't done anything other than set some instructions up. So now we can actually train our model. So we're going to define our model. What type of model am I going to use? A linear model or a logistic model? My response variable is the has little ones variable, which is 0 for no little ones in the room and 1 for little ones. Logistic, right? We have a binary outcome. We're not predicting a number. And to go back and answer Stella's question, what does step dummy do? So what step dummy does is, let's take a look at our training data set one more time. It takes a look at our factor variables, so our nominal variables, and creates dummy variables for them. So I think actually, even though this is not necessary for the model fitting, I can actually show you what happens when this recipe is applied. Because so far we've just shown you like, okay, here's a recipe and then let's apply it and take a look at the resulting model. But maybe looking at the data frame that gets constructed when we apply the recipe will be helpful in answering that question. So I'm going to try to remember. I think the way we do that is if we say, this right? I think that might be right. Oh. I'm trying to remember how we actually showed the data. And I don't remember it off the top of my head, but a recipe object. Maybe that was right. Okay. So this is like as a side thing to show what is happening here. So we started with a data frame, and I'll show what that training data set looks like here. That had 8 columns only, right? But if I apply the recipe to that data frame, you can see that I end up with 18 columns. So that's where the step dummy comes into play. So what happened? Stays and weekend nights, numeric variable, nothing changed. Adults, numeric variable, nothing changed. Daily rate, numeric variable, nothing changed. Has little ones, factor variable, but it's our outcome, nothing changed. But let's take a look at this resort hotel. Our hotel, the original variable was called hotel, and it could take the values resort hotel or city hotel. What the dummy variable creation step does is it converts their factors to a dummy variable. And so one of them becomes the reference level. In this case, that's clearly the city hotel. And then the other one becomes the non-reference level. So if the resort hotel variable has the value 0, it means it's a city hotel. If it has the value 1, it means it's a resort hotel. So we talked about, I think, introduced dummy variables last time when we first introduced multiple linear regression. The step dummy actually applies that. It might also be even more obvious with the arrival date month. Remember, these were categorical data starting with the month January, but we can see that January isn't there, but we have now dummy variables for all of the other months. So if for a particular row, I have zeros for all of the other months, it means that particular booking was in January. Or let's find one, this particular booking was in July, for example, because it has a 1 for that and it will have a 0 for everything else. So what the step dummy does is creates these columns. Could we create these columns manually? Absolutely. I could write some code that says, now create all these new columns, put zeros and ones or whatever. What step dummy is doing it all at once, because it's a very standard step to do. No, it can change. So the dummy variable can work with 2 levels where it becomes 0 or 1, or if you have more than 2 levels, then you'll get multiple dummy variables for that particular variable. I think I had this in one of the videos for the course where I had a kind of table with what all the possible dummy variable options were and kind of work through that. So reviewing that might be helpful as well. But did that answer your question, Stella? All right, great. Okay, so so let's go ahead and we said we are going to do a logistic regression. I know that we're running out of time, so I'll at least fit the model and show you the result. And then our engine is going to be GLM, okay? And then we can actually fit our model. So that's the model. And remember that we need basically a workflow to bring it all together. So I'll call it workflow. And our workflow basically is starting with our recipe, or starting with our model, sorry, add model. This is our model. And add recipe, which was this hotel's recipe. Oh, let's do this and then this. And then we can actually fit our model. It's basically this workflow. And when we're fitting, our response variable is has, oh no, we already defined our response variable in our recipe. So we just really need to say hotels training. Okay. So we can basically see all of those dummy variables here as well. So we have coefficients associated with all of them. In an effort to wrap things up here, we'll just take a look at these values for a little bit and just try to reason our way around it. What we're seeing here is that, for example, required car parking has a positive estimate. So that means that it's more likely to be associated with bookings that have where there are children. And in fact, that follows from what we had seen in our exploratory data analysis. But in our exploratory data analysis, we just said it seems like these variables have some sort of positive relationship with each other. And now we can actually quantify that relationship in a way that we can actually use it when we're doing prediction as well. So the next steps in our framework would be making predictions and taking a look at things like the area under the curves to evaluate the fit. And then what we're going to do next week is to say, okay, but we came up with these variables in some sort of a haphazard fashion, right? Which variables to fit into our model. We didn't really have a very principled way of selecting them. So we're going to talk a little bit more about how do we compare models to each other. So it's not just about fitting them, but also being able to evaluate them such that you can say, I think I'd like to do my prediction with model A as opposed to with model B. Does that make sense? Any questions about what we just walked through before I get into other more general questions? No? Okay. All right. I'll work on the quiz right after this. I'll stop sharing. If there are any other questions, I'm happy to linger and answer. And if not, we will see you all at the workshop tomorrow. It might be worthwhile to ping your team in however way you communicate with your teams, because I know many people are here, but not everybody's here, to just make sure that people show up to claim some tasks, because that's part of what you need to do in tomorrow's workshop, is actually kind of do some division of labor in terms of who's going to be working on what. I have gone through many of the project proposals. There may be just a handful remaining, so I'll get through them. But you'll have them before tomorrow, because one of the things I ask you to do in tomorrow's workshop is to make sure that everything there makes sense. But as I said last week, I don't anticipate necessarily anything revolutionary in those. Like, I've already given the comments that I'm going to. So explaining set seed again. So basically what setting a seed does is, when we are doing a random sampling, so the way R is doing random sampling is that imagine that it shuffles your data and then takes the top quarter of it or something like that. You can think about a mechanism by which you shuffle, where you can reproduce that same mechanism again. It might be a randomly generated mechanism, but ultimately what we're trying to say is we want to make sure that we're going to grab the same random sample. Let's think about it this way. This idea of setting a seed when things are truly random wouldn't work. So if I, as a human, would be doing random sampling by putting some chips or pieces of paper in a hat and reaching into it and genuinely randomly selecting them out, I don't think there's anything you can tell me that would make sure that I select the same set of chips from the hat every time I reach into it, right? But the way a computer does random sample generation is not like a human. It's not actually truly random. It's pseudo-random. It takes a starting point and then applies a formula to it, if you will, that has some randomness to it, and then says, I'm going to use this as my mechanism for selecting a random sample. So setting a seed makes sure that the next time the computer goes through that same process, it starts at the same starting point so that it ends up with the same random sample. And the difference between linear regression and multiple regression. So Multiple versus simple regression refers to whether you have a single predictor, a single X, or multiple X's. Linear versus logistic regression refers to, for example, whether your outcome is numeric or it's categorical. So actually, these are not mutually exclusive things. You can have multiple linear regression, or you can have multiple logistic regression. The simple or multiple is about the number of predictors. Linear or logistic or other types of regression, if we were to learn about others, is about the type of variable you're predicting. So linear for numeric outcomes and logistic for binary outcomes. So 0, 1 outcome. So if you're trying to predict success or failure or classify things into 2 categories, we're talking about logistic regression, which is what was in the videos this week. Linear for when we have a numeric, continuous numeric outcome that we're predicting, which is what we talked about last week. Is sensitivity the same as power of a test? The power of the test is, I believe the answer is yes, but I'm really bad with like binary classification in my head. Actually, I get so the power of a test is the probability that you correctly reject the null hypothesis, and the sensitivity is positives that are correctly identified. So yes, they are the same. Yeah. And we want them both to be high. Any other questions? All right. So family binomial is used for saying that. So remember that we said logistic regression is for modeling binary outcomes, right? But when we're fitting our model, that GLM, the function GLM in R, or basically when we say set engine GLM, that is a definition of a generalized linear model. It doesn't necessarily mean that you would have to have a binary outcome. There are other models for predicting multi-level outcomes as well. We're not going to talk about them in this course, but you would learn about them if you take a second course in regression. So family binomial is to say that my outcome comes from like a binomial trial, or a Bernoulli trial, saying that it can be 0 or 1. There are other statistical distributions like the Poisson distribution, the negative binomial distribution, so on and so forth. And we would use different families for predicting variables, outcome variables that have those particular distributions. So it is used for defining the distribution your outcome variable follows, so that it can be used to generate that link function in your model. The thing that's going to perhaps look a little bit funny in this course is that we're not going to learn about other families. This is a little bit because we're going to run out of time, and a little bit because logistic regression, this binary classification thing, is very, very commonly used. And in order to be able to teach about other sorts of families, we would really want to teach you a little bit of probability theory as well, which you'll learn in other courses first. So for logistic regression, we're going to focus on exactly binary outcomes, yes or no, 0 or 1, hello and jello, like whatever it is, but binary. How do we know when to use interaction effects and main effects? There are 2 answers to that question. One is maybe you're just interested in those estimates for the interaction effects because your research is in fact about do these explanatory variables have some interaction with each other? So let me give like one example. Let's say that we have data on, let's try to think of people who are left-handed and right-handed, okay? And light levels in a room, and we're trying to predict exam performance or something like that. Let's say we have some experimental data, and maybe we believe that how people who are left-handed are affected by light levels differently than people who are right-handed. If that's our hypothesis going into this research, we would want to have that interaction effect in there, because that's exactly what our research is about. And so in that case, you're probably not interested in like the best predictive model, but instead trying to estimate the relationship between these two. So in those cases, you would add the interaction effect because that's exactly what you're interested in your research. In some other cases, in more predictive modeling cases where we're not actually interested in those estimates that the model spits out, but just interested in predicting things correctly. So the example I gave in the videos for predicting things correctly was, you know, how Netflix does a prediction for you, or how Amazon does a prediction for you or something. They just want to know if you're going to watch the next thing or buy the next thing. In that case, you might go through some more automated model selection models, maybe, that evaluate, that considers interaction effects as well. And depending on some heuristics, they'll decide to keep that interaction effect or not. So we will go to the extent of mentioning next week that there are these automated selection methods, but I don't want to basically arm you all with a bunch of tools that does, you know, all sorts of selection without you actually understanding what it's doing under the hood. That's the sort of thing you would learn more about if you're taking like more of a machine learning course as well. So sometimes we use them because it increases predictive performance, in which case some automated model selection method might choose to use it or not. And sometimes we use them because we're genuinely interested in that interaction. You're welcome. Any other questions? All right, I'll stop the recording then.